open circuit. What happen? Consider if there is a one circuit having the 2 points A and B, through which open circuit is nothing but the resistance between these 2 points. Resistance between, if we have to measure the resistance between these 2 points, resistance is always infinitive. Means what happen? If consider this is a point A and this is a point B. Consider this is point A and consider this is point B. Point A and B, if we have to measure the resistance between these 2 points, there is no physical connection. There is no physical connection between these two units. There is no physical connection between these 2 units, and that point that is called as an open circuit. There is no flow of current through this point. That type of circuit is called as an open circuit. And if we have to measure the resistance between these 2 points, it is always infinitive. Then what is short circuit? Short circuit is nothing but, consider this is a point A and this is a point B. There is an actual physical connection between these 2 points with the help of small copper conductor or aluminum conductor. Generally, how many the resistance between these 2 points? Resistance between these 2 points is RAB is equal to always infinitive. RAB is equal to 0. And for open circuit, RAB is equal to infinitive. Generally, this open circuit and short circuit, these concepts are very important to solve the small numericals related to the DC circuit, as well as to find out the different faults in the different type of electrical machines, as well as to find out the fault in the different type of DC circuits. Then what is connection? Different connection. There are two types of the connection which is commonly useful in the exam point of view. First one is a series circuit and second one is a parallel circuit. Then what in by series circuit? When the two resistors are connected in series, means what happen? Consider the resistance R. This is the resistance R2, R1 and R2. The resistance 1 having terminal 1 and 2, resistance 2 having terminal 1 and 2. The second end of the terminal of resistance R1 is connected to 2. Means what happened? 2 is connected to 1. So this type of connection is called as a series connection. Generally, in the series resistance, equivalent is RS is equal to R1 plus R2. The current which are flowing through the two units R1 and R2 is same. Then there is a division of voltage maybe takes place. Means these three important relations are there. RS is equal to R1 plus R2, equivalent resistance. Voltage, total voltage V is equal to V1 plus V2, and I is equal to I1 plus I2. I1 is equal to I1 is I is equal to I1 is equal to I2. Means current is flowing through the resistance R1 and R2 is same, voltage is different, and equivalent resistance is RS is equal to R1 plus R2. Then second, generally what is the application of this series circuit? Generally this series circuit is commonly useful for the decorative lamps and other applications. Then what is meant by parallel circuit? Parallel circuit, the main application of the parallel circuit is generally for the household application of the different type of small electrical equipments. Then how this when the two resistors are there, R1 and R2, the first two terminals common terminals are there. One is first terminal of resistance R1 is connected to the first terminal of the second resistance. Second terminal of the first resistance is connected to the second terminal of the second resistance. Means common terminals are short circuited. Means 1 is short circuited and 2 is short circuited. Here in this case, equivalent resistance is 1 upon Rp is equal to 1 by R1 plus 1 by R2. Current which are flowing through this unit is I is equal to I1 plus I2. Then voltage is common, V is equal to V1 plus V is equal to V1 is equal to V2. Means if we have to compare the series and parallel circuit, in the series circuit current is common, and current is common for both the units, or current is same for both the unit R1 and R2, and parallel circuit voltage is same for R1 and R2. Generally this commonly useful for the household application. So this is about the small application of R1 and R2. Correct. Next point in the exam point of view, comparison between alternating current and direct current. As we know that this point is also very important, alternating current and direct current. Definition of alternating current. So there are 7 points in the comparison. Alternating current, what happened? First point is waveform. In the alternating current, waveform is sinusoidal. The waveform of DC current is straight line. Definition is, generally in alternating current, the magnitude and direction is changed with respect to time. Then in the DC circuit, magnitude and direction is same with respect to time. Use of this alternating current is commonly useful for the different type of AC machines, industrial application, household application. Then DC supply is commonly useful for the batteries, inverters and all these things. Efficiency of alternating current is less, efficiency of the DC current is more. Design of the electrical machines is very simple in AC. Design of electrical rotating machine, it is very difficult in DC. Generation of AC is very easy. Then generation of DC is very difficult. We can convert alternating current into direct current. Application of AC is commonly useful to convert the application of this AC is commonly useful for the household application, industrial application and other units. Then what is by application of DC is commonly useful of mobile charging batteries and other things. So these are the some point which is very important in the exam point of view.